of Computing in the annual International Research Conference 2022 of General Sir John Kothalavala Defence University. This technical session is based on the theme of Artificial Intelligence in Enabling Technologies for Sustainable Development and will be chaired by Dr. DDM Ranasinghe, Senior Lecturer, Department of Electrical and Computer Engineering, Faculty of Engineering Technology, the Open University of Sri Lanka. Ladies and gentlemen, I would like to invite President of the session, Ms. G.A. Yuvantika, to give you a brief introduction on Dr. DDM Ranasinghe.
Good morning, ladies and gentlemen. On behalf of the Faculty of Computing, I would like to welcome you all to the Technical Para Session 1 of the 15th International Research Conference of General Sir John Kothalavala Defence University. This technical session will be chaired by Dr. Menaka Ranasinghe. Dr. Menaka Ranasinghe is working as a senior lecturer in the Department of Electrical and Computer Engineering, Faculty of Engineering Technology, the Open University of Sri Lanka. She is the former head of the Department of Electrical and Computer Engineering. She obtained her bachelor's degree from University of Colombo, specializing in statistics. Thereafter, she started her MPhil degree in the field of artificial intelligence at the Open University of Sri Lanka. She was awarded a Commonwealth split-site PhD scholarship to University of Leeds, UK, where part of her research was carried out. In the year 2009, she completed her PhD from the Open University of Sri Lanka. Dr. Ranasinghe has held several academic and administrative positions in the university, including Director Staff Development Center as well. In the year 2017, Dr. Ranasinghe served as a visiting assistant professor at the South Asian University, New Delhi, India. Dr. Ranasinghe's main research interests lie in the broad area of AI and specifically in the areas of data science, machine learning, and cognitive systems. She has published many research papers and authored book chapters as well. It's with great pleasure that I invite Dr. Menaka Ranasinghe to chair the technical session. Thank you very much. Over to you, madam.
Good morning to all of you. I warmly welcome all of you to this technical session on artificial intelligence and enabling technologies for sustainable development. First of all, I would like to invite all the authors to the head table. Mr. Mihiraj Karunanayake, T.A. Gamage, J.K.S.L. Jayapodi. Yeah. Okay, any further delay, we'll start the technical session. Before moving to the session, I would like to brief you about few housekeeping rules. Each speaker will be getting 12 minutes and followed by a 2 minutes question and answering session. At the 10th minute, a bell will be sounded to indicate that there are 2 minutes remaining. And at the 12th minute, a bell will ring twice to indicate that the time is up. So that is all basically I have to announce as housekeeping rules. So without further delay, we will start the session. The first author is going to be Mihiraj Karunanayake. And he is a graduate from BSc, General Sir John Kothalavala Defence University on BSc Honours Degree in Electrical and Electronic Engineering. He has graduated in the year 2016 and he is following a MSc in Artificial Intelligence at University of Moratuwa. He has published few conference papers and presently he is employed as a research engineer at Electrical New Design Center of the Sri Lanka Navy. since 2018. His current research interests are embedded systems, Internet of Things, artificial intelligence, and marine control systems. The paper title is Knowledge-Based Expert System for Defect Identification and Rectification in Engine and Steering Control Systems of Fast Attack Crafts. Over to you, Mihraj Karunanayake. Until the presenter is getting ready, I would like to announce all the authors of the paper: KMCM, Karunanayake, P. Gunathilake, T. Kumara, and S. Nanayakkara.
Thank you, madam. Ladies and gentlemen, good morning. The authors flash on the screen are proposing the research paper based on the knowledge-based expert systems for defect identification and rectification in engine and steering control systems of fast attack crafts. The contents of the presentation are as flashed. The research area of the presentation is development of rule-based expert systems, and our specific area was focused to designing an expert system for defect identification and rectification in engine and steering control systems of fast attack crafts. So what is an expert system? In artificial intelligence, basically there are two categories as cognitive and non-cognitive or machine learning. So this expert system comes under this cognitive systems. So it is a reliable computer-based decision-making system which is interacting with an end user through a user interface. So expert systems will use both facts and heuristics to solve complex decision-making problems. So if you compare an expert and this computer-based expert system, this computer-based system can work for 24 hours continuously, giving his maximum accuracy all the time. But when we take an expert, human expert, even though he's the expert of that field, when he is continuously working for these 24 hours, due to the mental and physical burdens, his accuracy will gradually come down. And also this expert system is not only representing a one expert, it is a representation of many experts of that field. I will flash some characteristics of the expert systems. It is the highest level of expertise, right on time action, good reliability, flexibility, effective mechanism, and capable of handling challenging decisions and problems. This is the components of the expert system. The human expert represents all the experts of a respective field, and knowledge engineer is the main feature here. He is going to grab all the knowledge the expert person is having and put that into a knowledge base. So knowledge base is the domain knowledge. It has the knowledge engineer will convert this natural language of the human expert into computer language. And inference engine is the one, it is based on either rules or logics. It will convert this knowledge base into rules, and finally the user interface, it is the one the user is going to deal with. The motivation which guided us to do the research project was there are many defects probable in engine and steering control systems of ships. So when faults are indicated on the human machine interfaces of the system, so there should be an expert of the technical with technical knowledge to rectify that defect. So the fast attack crafts out at sea don't possess such expert knowledge to identify the root causes and rectify the defect out at sea. So we wanted to give a system where these technical experts are not available, but we have to cater that rectifying problem. So in such case, if that expert is not there, the fast attack craft needs to come a show for expertise attention and for defect rectification and identification at show. So thereby, the primary task of an fast attack craft is unattended out at sea, and also it will get very much vulnerable to the enemy attacks, as well as it will get a high cost for additional running hours. So that guided the problem statement as unavailability of an expert system out at sea for defect identification and rectification of engine and steering control systems of fast attack crafts. In our designed expert system, we focused on our own indigenous design naval propulsion and steering control system of fast attack crafts. This is a sample user interface of the possible alarms, which will appear on the human machine interface. So these are only a sample of the faults. So whenever one fault occurs, there will be many root causes for one single fault. So we have selected 14 such number of alarms along with their respective root causes as shown in the screen. So all these are technical faults, the electrical control system faults. So an electrical expert should be there out at sea to rectify these defects. So in order to design the expert system, we used a tool called ExisCovid. The advantage is that it's an offline system. So we can use out at sea easily where there is no internet. The knowledge base. The main thing the expert system having is the domain knowledge. So for example, the doctors, the scientists, likewise an engineer, there are knowledge bases in respective fields. So we gathered this knowledge from technical manuals, engineering knowledge, engineers, and the practical knowledge from the technicians. So we put all these domain knowledge into this problem solving system. The domain knowledge is fed into the inference engine of the expert system for next step. So here the knowledge representation technique we used is rules. There are some other knowledge representation techniques like rules and logics. This is one sample of the defect identification and rectification procedure we grabbed from a user manual. So we took a considerable amount of time for this knowledge base gathering. So all the data available in these manuals and from the engineer's knowledge as well as the engineering technician's practical knowledge, we grabbed those knowledge base and then we interface that with the inference engine using that expert system tool. So inference engine is the intelligent reasoning of the knowledge base by forward chaining. We use the forward chaining for this reasoning technique. So inside that tool, we modeled all this domain knowledge into a decision tree to figure out these rules. And meanwhile, we can give a certainty factor to check how much our output is accurate. It can be entered manually or either calculated by backward chaining. This is a sample page of the decision tree we used to convert our domain knowledge into the rule-based knowledge representation in the inference engine. I will show a small video clip how we evaluated it. So we need to first choose whether it is propulsion system or steering control system, and then all the possible false alarms will be indicated. And the non-expert person out at sea just need to follow the steps and the recommendations, the directives and the fault rectification methods recommended by this expert system. And just he has to mention whether he has done it correctly and whether the fault is rectified. If it is not rectified, this will give alternative solutions. So that's why I told there are many possible root causes for one single alarm. So all the possible root causes are addressed for our selected number of false alarms. So all these faults are technical faults. So an engineering expert should be there for rectification. So with the use of this expert system, any non-technical person also can follow these steps and easily rectify the defects out at sea. That is our main target. In the evaluation process, we selected a fast attack craft and installed this standalone offline system. You know that these engine and steering control systems, the defects are not happening in that much frequency. So we had to create these defects intentionally to evaluate our system. And we rectified the defects by several clients through the recommendations given by this expert system. The certainty factors were assigned manually based on the probability of correct solutions recommended by the expert system for any given false alarm. This is a sample of the certainty factors given for some false alarms and their root causes. All were above around 80%. So we accepted that it was a good solution for this problem statement. In conclusion, this study was conducted to introduce an intelligent defect identification and rectification system for fast attack crafts. A rule-based expert system has been designed to replace the technical expert out at sea. The domain knowledge of technical manuals, engineering experts, technicians, etc. have been used to model the knowledge base. And the inference engine and the user interface was modeled using the ExisCovid offline tool. The design system was tested on board a fast attack craft with different clients for performance evaluation, and we obtained over 80% accuracy. As future work, we would like to recommend to develop a machine learning model to predict the certainty factor of the recommended solutions by the expert system. So, since it is a machine learning model, it should have much data. So, we are going to install this on board several boards and monitor for several years and collect this data for machine learning model. So it will be a future work of this research project. These are the references we followed. And we would like to acknowledge all the officials of the Naval Dockyard Trincomalee for their valuable contribution and guidance during this project and also for this paper representation.
Thank you very much. Now the session is open for question and answering. Any questions from the audience?
So we use several clients, and for same defect, we got the output of the several clients through the expert system, and we calculated the probability out of the recommendations of the expert system over the actual, for one defect about 10 only. Yes, it vary around 9, 8, 9, 10, around that. For 14 defects all, because one defect has around 3 to 4 root causes. For each and everything, we had to calculate this certainty factors.
Can I ask one question?
Yeah,
so you have already mentioned that you have already created the defect intentionally,
yes,
to get the results. What do you think, like if you doing like that for a research purpose, so do you think it is a good method, or what is your idea about that?
Yeah, madam. As per our experience, we know that these defects are not that much probable out at sea.
Yeah.
But if one defect occurs, it will cost a huge amount as well as the risk of life.
Mm-hmm.
So in this research, what we wanted to do was to at least reduce that risk out at sea, and to evaluate. We intentionally, that we know by experience, these are the probable defects.
Mm.
So intentionally, we made the defects. For example, by simulating, we can give a high temperature alarm or low pressure alarm by simulators. So the end user will don't know what is the root cause. The technician will give that alarm, and we are observing what the client is doing with this expert system. And the recommendations through the expert system, what he is acting, we got the certainty factor as the correct to evaluate our design.
You have mentioned that there's a certainty factor.
Yeah,
that is the only factor that you have measured to say that this one is working properly. So can you suggest something else? Do you have something else to say that to measure the accuracy of the system rather than this factor?
Yeah, madam, that in these cognitive systems, since it is a rule-based system, it has alternate solutions. So as per literature, that it was the certainty factor was the literature factor that came for this evaluation purpose of an expert system. So we followed that one, and that certainty factor calculation, we have multiple types like manual engineering, machine learning models, and this probability calculation likewise. Other
Sri
than
Lanka
that,
Navy
we did.
uses another method, Sri Lanka Navy, to up now.
Sorry, madam.
Apart from your method, is there any method?
No, madam. No. The boat has to come ashore for technical expert assistance.
Thank you.
Thank you.
I have another question. You said that there will be a technical, basically an engineer in the naval ship, and he will be attending to the technical issues, whatever suggested by them, because manually will be done.
In the evaluation process, madam. Or out at sea.
The rectifying the problem.
No, madam. For the evaluation purpose, we put him inside the ship. But actually, when the fast attack craft is going out at sea for patrols, and the engineer is not going with it.
Are not going with him. So,
Yes.
okay, anyway. So when he comes, what kind of a process have you been adapted to? If you want to embed new knowledge into the system, is it again to manipulate the rule-based systems, or how is there a
No, madam. So we have expertise. So in addition to this expert system, we have by experience, the expertise can attend the more than this, its accuracy is, that means high than this
Okay.
expert system.
All right. So what I'm asking is how you manipulate the knowledge base. So is there an automated system, or do you have to redo the knowledge base again if you want to embed new knowledge? Have you thought of?
Yeah, we have to manipulate it again, madam. Yes.
Okay, right. Thank you.
The decision tree, we have to make it again,
All
madam.
right.
There is
Good
one
morning.
question from the Zoom, I guess.
Can you hear me?
Yes.
Yeah. Couple of questions from my side. Now, this is a one-to-many kind of a mapping, what you are trying to do. When you generate those intentional defaults, did you generate the same number of defaults for all the criteria? So what's the method that you followed?
No, sir. Actually, we have by the experience of the past data, we have a priority of the possible defects and their root causes. So we first prioritize those defects, and the number of times we repeated the false alarm, the manually creating the defect, it depended on that priority basis, sir.
Yeah, then your results will anyway bias to that the creation of defaults. So it's not maybe fair.
We
that
had these
means-
limitations, because we selected 14 number of false alarms.
Yeah, if you take a one particular fault, you showed let's say 4 root causes. If
Yes.
you need to show that confidence level, you need to generate the same number of defaults for each root cause. Otherwise, your results will be biased to one of the root causes.
Yes.
Then when you evaluate, how many trials did you try?
For each root cause, it was around 8, 9, 10 times. For the priority
8, 9.
basis, it almost 10, and it
Okay.
depended as per the priority, sir.
Okay, maybe you can try with the same number of trials as well. So that gives better results. Then you said that with the user experience, you said that you get the feedback from the user in your system. Will the system be improved with that feedback? Is there a mechanism for that?
Yes, sir, there's an issue. That means we are configuring this inference engine based on our domain knowledge. So if the user feedback is not up to that certainty factor, then we have to manipulate that domain knowledge again with more domain knowledge data, sir.
Okay, so that means the system will be more improved with time, is it?
Yes, of course. Considerable time was taken for this collecting of data from into the domain knowledge, sir. So
Yeah,
the total,
yeah. One maybe last question. what happen if multiple alarms came up together? Is there a way to solve?
No, sir. It is
This time?
forward chaining type. So after one rectification, the end user has to go for the next one, sir.
Yeah. So ultimately, this system, underneath the system, you have a one-to-many kind of a mapping. You have a table.
Yes.
From that, you pick these solutions. Is it what happens?
Yes.
Okay. Okay. Thank you very much. Okay.
Thank you, sir.
In the absence of any other questions, thank you very much for this really good presentation.
Thank
So
you.
with that, we will move to the next presentation on integrating artificial cognitive systems in smart agriculture. The authors are T.A. Gamage, EMNM Ekanayake, RMNM Rajapaksha, MTD Mackonal, and DGM Ranasinghe. The presenting author is Ms. T.A. Gamage. T.A. Gamage is a final year undergraduate following the BSc Honours in Software Engineering degree program at the Department of Computer Science, Faculty of Computing of General Sir John Kotalala Defence University. And currently she is doing her internship at Virtusa Private Limited as an associate engineer technology. Her research interest includes artificial intelligence, effective computing, and distance learning. Over to you, Tamul.
Good morning, everybody. Our research paper title is Integrating Artificial Cognitive Systems in Smart Agriculture. I'm T.A. Gamage, and the co-authors of this research are EMNM Ekanayake, RMNM Rajapaksha, MTD Mackonal, and Dr. EDM Ranasinghe. And we are the first four authors are from General Sir John Kotalala Defence University, and our supervisor, Dr. EDM Ranasinghe, is from the Open University of Sri Lanka. So this will be the content of our presentation. So we'll move on to the introduction. So first of all, we'll see what are artificial cognitive systems. So as the name implies, artificial cognitive systems are the systems that are embedded with cognition artificially. So as humans, we all have cognition, which is embedded to us, but still with systems, we have to embed artificially. And also systems that act on their own to achieve goals and perceive the environment, anticipate the need to act, learn from experience, and adapt to changing circumstances are known as artificial cognitive systems. And according to the Cambridge Dictionary also, cognition is connected with the thinking or the conscious mental process. So then we'll see why cognitive systems are important in agriculture. So cognitive computing is one of the important areas of AI, and researchers in this field obtain inspiration from human cognition. So some of the advantages of having cognition in smart agriculture are the improved work efficiency, reduced human error, and strengthening the knowledge available in how humans process information. So as humans, we all depend on agriculture. So agriculture is one of the significant sectors in the world. And the use of fully automated robots are highly noted in several stages of agricultural process, although they are not fully cognitive. So then we'll move on to research methodology. To support this research, we have utilized 3 research questions. First one is how the agriculture has been affected by the concept of smart agriculture. For that, we have used 3 agricultural concepts. And then what are the challenges faced by the smart agricultural paradigm? And finally, how artificial cognitive systems can be integrated into smart agriculture in future research, because full cognition in artificial systems are not achieved by now. So for literature review, we have utilized IEEE Explore and Google Scholar databases with a concern from literature from 2015. So then we'll see the agricultural aspects. So we have considered on 3 agricultural aspects. Namely soil, crops, and plant diseases. So we'll move on to soil first. So as of the agricultural aspects, we have utilized 3 agricultural aspects. So for the agricultural aspects, we have used So we'll move on to the agricultural aspects that we have considered in our research. So first of all, it's soil. So when it comes to research in smart agriculture based on soil, many research have focused on soil sampling and even taking the necessary steps after obtaining the soil information like spraying pesticides and even fertilizing. So a four-wheeled agricultural robot has been implemented with the touchscreen feature for command generation to obtain soil information in 2017. And a six-wheel soil sampling mobile robot has proven for its efficiency in the productivity of agriculture. And other than that, the integration of IoT is also available in current research. And in 2015, a robot that collects data on soil moisture and temperature at some specified points in the field has also been done by some of the researchers. And actually, like this says, it is at some specified point. So obviously, we have pre-programmed the particular robot to do that, but it does not have any cognitive capabilities, like to identify, like humans, which place is the best place to identify the particular soil sample for soil information retrieval. So then, and another great achievement in soil-based research in agriculture is the invention of the EMNM protocol, which works in real time without any internet connectivity. So this is actually a great achievement because this does not require any internet connectivity, so that in rural areas as well, we can use this particular robot. And it has the capability of monitoring the humidity of soil, temperature, and even the humidity of air. So a robot to move to any specific location has been developed in 2020 within the crop and water the plant. So again, without just limiting to identifying the particular soil information, a next step has been achieved where watering the soil is also being done. However, again, this is based on predefined time period. So it does not have any capability to identify whether it requires water or not. It will water with predefined time period. And a robot to fertilize the soil autonomously has also been developed, and it has been proven for its efficiency in gardens, agricultural and horticultural fields. And then we'll move on to crops. So crops is also an important aspect in agriculture because crop harvesting, seed spreading are really important when it comes to crop management. So drones has been utilized for distinguishing between crop rows, flow plowing in field using RGBD sensor, and further work of this research done in 2015 is to achieve a high resolution using new sensors. And seed spreading is also an important part because if the agricultural area becomes really large, it's really difficult for the farmers to move around and do the seed spreading. And however, some research just minimize with the seed spreading process. So a research with in 2019 has done for performing seeding on a fixed distance or every required distance in the agricultural field. As further works of this research, they are to embed intelligence to pick weeds as well, because having multiple processors in one robot will really help things. And then an agribot in 2016 has been developed for the seeding process using precision agriculture concept with optimal depth and distance. And also crop row identification plays an important part because the robot really has to navigate in the agricultural field. So this robot has been developed in 2020 using clustering algorithm, which is a mobile robot which can navigate between the crop rows. So crop harvesting, again, is an important thing when it comes to crop management, because again, when the area of the agricultural field becomes really large, it's difficult for the farmers to go around and harvest the particular crops. And a successful harvesting robot has been developed in 2020 with the use of an iRoboria controller. So then we'll move on to plant diseases. So the two types of plant diseases are basically the abiotic and biotic. So in 2018, a plant health monitoring system for the early detection of plant health with image acquisition with crops has been done for leaf health disease detection. So actually some research have gone for just leaf health and some have gone for the whole plant as well. So however, some research also concern on the further step of spraying pesticides for after detecting the particular plant disease. So a robot in 2020 has been developed for the purpose of spraying pesticides, and it can be handled with mobile phone. So it's really clear that although we have developed robots, we are not so sure about them. So that's why we have some control on the robot that we are implementing or designing. So then in 2021, the an autonomous robot has been developed that detects plant diseases and apply pesticides. So this has gone for the next step of applying pesticides after detecting the plant disease. Another robot has concern only on the leaf disease detection in 2021. And in 2020, a voice controllable robot has been developed after the detection of accurate disease by the robot. And this has the capability to alert the particular user, maybe the farmer or the particular owner of the robot. And it provides with the measures that can be taken after detecting the particular disease. So, however, the farmer or the owner of the particular robot has the ability to identify the real countermeasure for the disease that it has identified and to take the necessary actions as suggested by this robot. So then we'll move on to the challenges to smart agriculture. So we have identified these challenges to the concept of smart agriculture, namely power consumption, hardware and networking issues, signal communication, reliability and scalability, awareness and knowledge between the farmers, because sometimes it's really hard for farmers to be aware of these things because there are a minimum number of awareness sessions, and even some research just limited to the research work but will not be really put into the agricultural field. And data security and business security are some of the other challenges that are faced by the smart agricultural paradigm. So then we'll move on to the integration of cognition into smart agriculture. So we are proposing hybrid approach, which is a combination of cognitivist and emergent approaches. So first of all, we'll see what are cognitivist. So in cognitivist approach, the particular cognitive robot only has the particular pre-programmed memory or the knowledge. So it do not learn from new experience. But when it comes to emergent approach, it do not have a pre-programmed or embedded memory to it or any knowledge. It will have to learn from the experience. It has to learn from the experience. But we are proposing hybrid approach, which is a combination of cognitivist and emergent, which will also have some knowledge which we are embedding to the system, because definitely the robot should have some knowledge to do something, and even it can learn from new experience with the hybrid approach. So as case studies for the integration of cognition, we propose to have the ability of deciding whether the designated place is the most suitable place for collecting the particular soil sample, and to identify the weather condition again, because like I said earlier, if we water the plant or the agricultural field again and again, it won't make sense. Like if it is already rained or about rain, there is no need of watering the particular field again. And to analyze the soil fertility and fertilize accordingly, and the identification of the most suitable place in the field to plant for the seeding process of the planting. So these are some of the case studies we propose in future research. And as conclusion, so artificial cognition concept allows a fully automated robots to work beyond predefined rules and facilitate learning and interact with the environment. And also the integration of IoT devices and future inventions will really helpful, although the cognitive robots are not achieved in smart agricultural process up to now. And we propose hybrid cognitive architecture, which is much more viable for embedding cognition artificially to smart agricultural systems. And we will think the identified challenges for smart agriculture will help future research to improve them. So these are the references, and thank you very much.
Thank you very much, Ms. Gamage. Now the floor is open for question and answering.
So your whatever the conclusions you have proposed, have you done any thing like, so how can we economically put that into the practice in Sri Lankan context to our Sri Lankan farmer sections?
Yes, madam. Actually, these cognitive robots have not been achieved by now, because there are some research gaps in how humans process information, and also how to embed these things artificially to robots, because we really don't know how as humans the thinking process happens. The research goes on. And so, yeah, in future, we will be having those cognitive robots in smart agriculture. So definitely, if we take about the Sri Lankan context, yeah, farmers should be aware of how to use these systems other than the fully automated robots and the cognitive robots.
In the cost factor, what do you think, like when you are going to implement in
to Sri Lankan context?
Yeah, it will cost somewhat, but still, because already these systems have not been achieved yet, like the cognitive things, we can't have an estimate because we don't know how the things happen in reality because these have not been invented yet. But requires for the context involved for the agriculture.
Indika, do you have identified any kind of crop that where you can apply this kind of system in Sri Lankan context?
Yes, so rice cultivation, the paddy cultivation, we can use for harvesting and those things, but still we are mainly focusing on the cognitive robots. So since these have not been invented yet, we cannot say, we cannot give a full answer, but still we can have these fully automated robots for seeding process, crop harvesting, fertilizing and detecting plant diseases, because these are being used widely around the world. So yeah, as Sri Lankans, the government can take obviously can take necessary actions to have these in our fields.
Actually, in Sri Lanka, it's good, like now, and if you say paddy and other vegetable and things, if you can apply this kind of high-tech systems, that will be great. But the thing is, you won't be able to sell anything for consumers if you apply this kind of thing. But the thing is, there is still we do have a space and requirement, especially in the state sector. Now, if you know that when you say cognitive robots, of course, they can have the ability of self-learning and apply the situation according to the situation. That's the main advantage in this kind of situation. System. Like if you say we have a big problem in Sri Lanka for tea pluckers in estate sector. I don't know whether you have heard about it. Rubber tappers in the there is a big scarcity and there is a problem in the sector, and especially and in the tea pluckers. So if you can develop this in commercial scale, there's a good market, good demand, especially for rubber industry. We have a huge problem. So if you can develop this kind of cognitive system, because you know, in the rubber, if you have studied the rubber tree, the situation is going to be, changing. It is not possible to mechanize. Rubber tapping is not possible to mechanize. Definitely, you have to go for this kind of high-tech situation. If you are going for computerization or technological applications, so you have a huge potential in Sri Lankan context, not only in Sri Lanka, worldwide. If you can develop, that will be great.
Okay, thank you.
I have one small question. Now you have listed some of the challenges in implementing smart agriculture. Do you think culture in Sri Lanka is a challenge for smart agriculture, or do you think it is not a very serious concern?
I think it's a moderate type, because if we do the necessary awareness sessions to give farmers who are involved in the agricultural process, so definitely they will understand how these things can be used. But still, yeah, culture is some sort of challenge, obviously, because in Sri Lanka, most of the farmers are used to do with their own the things manually. So if we are to definitely propose these systems or introduce these things to them, so we have to have some awareness sessions around Sri Lanka. Yeah.
Actually, I'm also a farmer. I'm running my own farmhouse, but the Sri Lankan context, as Dr. Asel, I think, said that application side will be a problem. As software engineers, we like to propose and we like to have systems. But when it comes to farmer side, of course, they don't need systems because they have their own systems for normal cultivations. But the thing is, first we have to see whether is there a real requirement for paddy cultivation and other vegetable cultivation and other crops. But as I said, there are sectors that we need technology. So please, like if you can have some kind of further research on that kind of area, we have a huge potential, and there is a national requirement for this kind of innovations and applications and establishments in Sri Lanka, not only Sri Lanka, in worldwide. So if you can start your researchers, like from the, but still, I mean, from starting from the requirement analysis, you have to see the real requirement. Please don't try to dump something that we have already developed for farmers. Definitely it will be rejected. It won't use. It won't be applicable. So if you can identify places where really the requirement is there, that will be more successful.
Thank you so much.
Actually, what I observed is you have done some kind of literature survey about artificial intelligence application is in culture, agriculture. So in Sri Lankan context, it is really difficult to apply artificial intelligence into such a agriculture, because robotics is the fundamental things, because if the robotics is not developed in such case, so we cannot apply machine learning or artificial intelligence into the just a system. So robotics has need to be improved in the Sri Lankan context. Have you done any literature survey? Is it possible that we can apply this AI or machine learning into directly to the agriculture?
Yes, so actually we have not only focused on the Sri Lankan context mainly. So we have reviewed work since 2015. And so from things that we have identified, what we can say is that the robots have been developed which are fully autonomous. Obviously, this has been achieved, like for seed spreading, for all those things that I said. But the cognitive concept is a new thing because there is some research gap in how humans do the thinking process and how to embed these things artificially to system. So this has not been achieved in anywhere. Although there have been like hybrid approaches and the models or the architectures that have been proposed yet, fully cognition is not achieved in smart agriculture. So if we take Sri Lankan context, yeah, we can first make people aware of the fully autonomous robots that have already been developed and make them aware of that and have them in action in agricultural fields. But then only we can go for the cognitive aspects.
All right, thank you very much, Ms. Gamage, and thank you very much for these insightful questions as well from the audience. So we will move to the next presentation on touchless Palmprint recognition system using image processing. The original presenter for this paper is T.N. Nicklesha. She is following a BSc Honors Computer Engineering degree program at the General Sir John Kotharawa Defence University and currently doing her internship at IFS R&D International Private Limited. As a trainee software engineer, her research interest lies in the mobile application development, software engineering, and human-computer interaction. The paper will be presented by the author, MAST Gunathilake, and all the authors are T.N. Nicklesha, DMR Kulasekara, and MAST Gunathilake. So today the paper will be presented by MAST Gunathilake.
In all, this is the paper titled Touchless Palmprint Recognition System using Image Processing. Actually, the authors are T.N. Nicklesha, DMR Kulasekara, and MAST Gunathilake. Due to an unavoidable circumstances, T.N. Nicklesha is not attending to this session. Therefore, MAST Gunathilake is presenting this paper. First of all, let's see the table of the content: introduction, problem, solution, aim, design, technologies used, results, and finally the references. Currently, we are facing to a high pandemic, COVID-19 pandemic. Therefore, in day-to-day life, it is very important to identify people mainly for security purposes. And we have to use different types of biometric systems to verify person and comparing physical structure or behavioral characteristics. Among these characteristics, palm print biometric system is special compared to other biometric systems for mainly many reasons. Actually, what is the problem? As I mentioned earlier, we are facing to a pandemic, COVID-19 pandemic. Therefore, we are wearing masks, face shields, and accordingly, people couldn't recognize by identity card photo comparing with the face in day-to-day works. And also, there are fake fingerprints as well. Not only that, but also there are a lot of thefts and rackets happen because of this situation. What is the solution then? We can propose a more fruitful and novel solution to overcome this problem. What is that? If we verify people with their palm print, there is no problem with wearing masks and face shields. If the verification system is touchless, it is good for privacy and sanitization of society. What is the aim of this project or the paper? The aim is to design and develop a touchless palm print recognition system to verify people with low quality palm print images and give fast and high accuracy results. Let's see the methodology and the design of this system. This system is comprised of mainly two modules called enrollment module and the identification module. Enrollment module can be further classified into 4 sub-modules: palm print acquisition module, palm print pre-processing module, feature extraction, and find the database. While the identification module can be divided into 4 sub-modules: palm print acquisition module, palm print pre-processing module, feature extraction module, and the matching module. And altogether, the database module and the matching module is connected each other, and it produces some kind of result, and we call it as the verification result. The technologies used for this project is Raspberry Pi, OpenCV, Python and Thinker. And these are the testing results of this project. In the first image, you can see the original palm print image in RGB. And secondly, you can see the grayscale image. Then thirdly, precise grayscale image. And we pre-process the image like this according to the fourth image. And finally, we get the feature extracted image, which is compared with the database. And furthermore, we have more results for this palm print matching recognitions, blurred images and rotated images. And this testing shows more accuracy results. And these are the references of this paper.
Thank you very much, Ms. Gunathilake. So now the floor is open for questions and answers. Then shall I start the question and answering session? In this, you have said, what is the measure that you have taken to identify the maybe with the palm, what you call this, I don't know the exact wording, but how do you identify these exact, you measure in the distance or?
Yes, first of all, madam, we are taking an image.
Yeah.
Then we, according to the methodology, first of all, we get the palm print. It's the palm print acquisition means, first of all, we get an image. Then we pre-process the image, we filter that one. Then we do the extraction of the features. That means these lines of this palm print. And it is sent to a database.
Okay, so what I'm asking is, how do you exactly identify the lines, whether it's directly one-to-one pattern mapping, or whether you identify with the distance?
With the distance, madam.
With the distance.
Yes, considering the distance.
Okay, so it's only the distance, direction, and other aspects has also been taken?
Yes, madam.
Okay. Any other questions? All right, then we will move to the.
Can I ask one question?
Yes.
Yeah. Now this, when you store the data in database for comparison, did you do exact the same procedure, or you, what's the procedure
Yeah,
there?
yes. So according to the methodology, we have same modules. We do all these things to the existing Palmprint image as well, and we compare the results of the database with the machine results.
Now, when the number of entries are high, is there any particular way to speed up the search?
No, that will be do as a further work. Still, we
Further
are in
work.
the process of acquisition part, pre-processing part, and the feature extraction part.
Yeah. Can you, last question, can you a little elaborate on the algorithm that you followed to get this mapping? What I didn't get what you said was distance and something like that. I didn't get that, sorry. So can you elaborate on that? What's the process that you follow?
Yeah, I think she's the supervisor of the project, so the students may have been carried out the
Original
work.
supervisor is the DMR Kulasekara madam. He's the
Okay.
original supervisor, and I'm the co-supervisor.
She is a co-supervisor, so we'll defer that question. And I think you can contact the original author, delegate the question to the original author, and convey the answer to the audience. Thank you very much. So is that all right?
Yeah, all good, all good.
Okay, right. Thank you very much. So with that, we will move to the next presentation. Thank you very much. The next presentation is on data retrieval and analysis to identify the associated people of Instagram using image processing. The presenter is JKSL Jayakodi. Mr. Jayakodi is a final year undergraduate student following the BSc Honors Software Engineering degree program at the Department of Computer Science, General Sir John Kotalawala Defence University. He is currently working as an intern software engineer at Sri Lanka Telecom, and his main research interests are artificial intelligence, data science, machine learning, and networking. Over to you, Jayakodi.
Thank you, madam. Good morning, everybody. I am JKSL Jayakodi from Faculty of Computing, General Sir John Kotalawala Defence University. My research topic is data retrieval and analysis to identify the associated people of Instagram using image processing. This is the outline of my presentation. In the modern world, social media has become an extremely important part of our lives. The platforms such as Facebook, Instagram, WhatsApp, Viber, Twitter have become essential for everyone. So when concerning about Instagram, people share thousands of images, posts, or comments on their accounts. But sometimes these images, posts, or the comments influence for the national security of a country. This means some people misuse Instagram for the illegal activities such as sharing false propaganda, sharing fake news, to do the terrorist activities, unethical religious activities, and illicit drug distributions. So unfortunately, many of the times it affects for the murders, crimes, or suicides also. Especially when concerning about Sri Lanka, day by day, these kind of illegal activities are rising. So it is very important to develop a system to retrieve the data from Instagram accounts and analyze that data to identify who are the most associated people of a certain Instagram account. So when concerning the problem, the main problem that we focus, the misusing of this Instagram platform. That means, as I mentioned earlier also, some people misuse this Instagram platform for the illegal activities such as sharing false propaganda, sharing fake news, to do the terrorist activities, unethical religious activities, illicit drug distributions, etc. So unfortunately, many of the times it affects for the murders, crimes, or suicides in a country. So when concerning my literature review, I have divided this into two parts. The first part is data retrieving and data analyzing technologies. And the second part is face recognition and face similarity checking technologies. So when concerning data retrieving and data analyzing technologies, we can retrieve different type of data from Instagram. Some of the examples are like text, comments, images, or the post. So according to the research papers I have referred, it says that Instagram can be used for demographic analysis, text analysis, image analysis, and also for the age detection processes. And according to the existing researchers, we can use the technologies such as snowballing method, the coding rules, the binary coding method, and regression analysis to collect image data by Instagram. So when concerning snowballing approach, it was used to acquire the visual data from individuals. The photos were self-coded using the binary coding method, and the behavior of the users were examined by using regression analysis. When concerning the face recognition and face similarity checking technologies, the face recognition and image similarity checking process is mainly and very popularly used in iPhone photos and Google Photos. So when concerning the face recognition technologies used in iPhone photos, at their first stage, they use the Viola-Jones detection technique. And then they develop it into deep convolutional networks. And after that, they use network-in-network technology. So when concerning the face recognition and face similarity checking process, this teacher-student training methodology was their next step. And then in present, the deep neural networks are the technique that are used by both iPhone photos and Google Photos. So when concerning the other face recognition technologies, that can be used rather than the technologies used in iPhone photos, they are Eigen Faces, neural networks, graph matching, and lineage mapping. So when concerning the Eigen Faces, it's useful for face recognition and detection by determining the variance of faces. When concerning neural networks, it's the most popular face recognition technology that can recognize the face through learning the correct classifications of the coefficients. So when concerning the graph matching, this is an algorithm in the computer vision for recognize the objects or the object classes by using the graph representations. So the lineage mapping. Lineage mapping is also a technology that integrates the structural information with spatial information by using the line segments. So this is a comparison table on the face recognition technologies. So when concerning the Eigen Faces, the main advantages are the simplicity is high, it's much effective than the other technologies, and it saves the time and the space. But when concerning the disadvantage, the main disadvantage is it's sensitive for the lighting conditions and the head positions. So when concerning neural networks, the main advantages are the accuracy is high, the feature extraction is more efficient than the other technologies, and the classification time is very low than the other technologies. So when concerning the main disadvantage, it needs much storage capacity than the other technologies. When concerning graph matching, the main advantage is if any of the features are changed or are missing, the people will still be identified. But when concerning the disadvantage, it also has the same disadvantage as the Eigen Faces, that means sensitive for the lighting conditions. So when concerning lineage mapping, it's insensitive for the lighting conditions and it has the cheap memory requirements. But the main disadvantage is the computing requirements and the specifications are much higher than the other technologies. So when considering this comparison table, according to the advantages and the limitations, the most suitable technology for my system will be the neural networks, because the neural networks are more speedier, more efficient, and it has high accuracy than the other technologies. So when concerning the aim, the main aim of my project is to develop a system to retrieve data from Instagram accounts and analyze that data to identify who are the most associated people of a certain Instagram account. So when concerning the proposed system, I have divided this into two major parts. The first part is image retrieving and image scraping process. And the second part is face recognition and face similarity checking process. When concerning image retrieving and image scraping process, when we concerning the Instagram image retrieving and image scraping process, we can use different type of web scrapers. So some of them are Selenium, Beautiful Soup, Playwright, and Mechanical Soup. So among the above mentioned web scrapers, the best web scraper for image scraping process will be the Selenium web scraper. So we can use it with Python. And when concerning the face recognition and face similarity checking technologies, the neural networks are the most suitable face recognition and face similarity checking technology for my system because it's more speedier, more efficient, and it has high accuracy than the other technologies. So this chart will show the overall methodology of my proposed system. So I'll explain it one by one. First, we scrape all the images of a certain Instagram account, and then we classify these images into positive and negative images. In here, the positive images means images with human, and the negative images means images without human. So by taking all of these positive images, then we give an input facial image of the person that we need to find who are the associatives of that person. So by giving that input facial image, then again the system will classify whether the person is available or not available in those images. So if the person is available, then again the system will classify it into group images and single images. So by taking all of the group images, it will extract all the faces of the people in these groups and then check the overall similarity of each face. And finally, by using the probability, it will identify who are the most associated people of a certain Instagram account. So as the conclusion, data retrieving, data analyzing, and face recognition technologies are very popularly used in the modern world for many of the applications. So in my work, I have discussed various data retrieving, data analyzing, and face recognition algorithms along with their benefits and the drawbacks. So, and also I have discussed the methodology for the newly proposed system to identify who are the most associated people of a certain Instagram account. So these are the references. And thank you very much.
Thank you very much, Mr. Jayakodi. And now the floor is open for question and answers.
Are you going to do that? Do you access to the how it is happening?
Yes, sir. That means we are using a specific Instagram account for this project. By using that Instagram account, we are searching for the person. And then by using a web driver called Chrome web driver, and by using that, we can automate the Instagram. So by using that and the Selenium web scraper, it can scrape the images of the person that we need.
So anyway, to identify a particular person, you have to find somewhere in the line, some account in the line.
Yes.
You analyze what is the legal side behind this particular project? In
Yes,
legal sides, we have to continue this because it's for there are legal aspects related to this one. So have you gone through and analyzed? Is there any legal things behind it?
Yes, madam. We did these presentations and discussions with the National Intelligence Unit also. And the only one issue has that we cannot access the private data of the Instagram, but we can scrape all the public data from another user.
Okay. So if the government is planning to, for example, like if you are doing that, if you are going to implement that in the Sri Lankan context,
yes,
will there be a problem like without in the government, you know, in the government, there may be sometimes y'all, they will ask you all to closely get the informations from the
particular Instagram accounts and do the things. What do you think about that?
Yes, madam. For that, we have to get the permission.
Yes.
But according to the
yes, but it's like it's a kind of a privacy issue of particular people. So what do you think about the privacy side?
In here, madam, we are focusing on when some person has been caught for this type of illegal activity, we can find the groups of people who are doing and involving with these kind of illegal activities by using that person's Instagram account.
Is the in our Sri Lankan legal sector is covered to protect these type of incidents from?
Yes, madam.
Thank you.
Okay, I have one question. You have mentioned in your conclusion that the suitable method to implement this one is neural networks. So on what basis that you are giving that kind of a statement? Do you have any quantitative measurements?
Yes, madam. That means according to the testings, that means we can use the Eigen Faces, neural networks, lineage mapping, and graph matching. So according to the testings, the most efficient process is neural networks.
So you mean by the literature?
Yes, ma'am.
Okay.
According to the existing researchers and research papers.
Okay, thank you.
I have a question. If there is a twins or triplets outside in the same similar phase, is there any option to identify them separately?
Yeah, we are recognizing the birthmarks and the line segments in our face. So sometimes the twins can also have the different line segments in their faces. So we can identify by that. Oh, okay.
I have. No, you go ahead.
Yes, sir. Yes, in the literature review that some of the research papers have done these kind of works for the twins also, sir. So by that they can they have given the results that they can identify the twins also.
I have one question. So sometimes there are fake accounts.
Yes.
So sometimes it can be a replication of the original one, where unknown person has created that in lieu of another person. So by using these techniques, is there any possibility to verify that kind of identification?
No, madam. Still, we don't use that one.
Yeah, because that will be a good thing if you can cross-check and verify in that direction as well, because that is a major problem.
Yes.
Okay, thank you.
Can I have one question?
Yes, please go ahead.
Yeah. Sorry, I think I missed one part of the presentation due to the internet connection. But did you say that did you implement this algorithm and evaluate the performance?
Yes. Still, we are implementing this system, sir.
Okay, so your implementation has not been done yet, but you are intended to do that.
Yes, sir. We are
Okay.
in the image phase extraction process. We are still in that phase extraction process.
Okay, thank you.
All right, thank you very much. Thank you very much, Mr. Jayakodi.
Thank you.
So we will move to the next presentation. The next presentation will be on driver emotion recognition for safe driving, a comprehensive survey. The authors are T.A. Gamage, EARC, Sandamali, and P. Kalansooriya. The paper will be presented by T.A. Gamage. So I don't think that I need to give an introduction to her again, because she has presented and it's the same biography. So without taking any further delay, I will hand over the session to Ms. T.A. Gamage. Thank you.
Good morning, everybody. Our paper title is Driver Motion Recognition for Safe Driving, a Comprehensive Survey. The authors of this research are T.A. Gamage, Ms. EARC Sandamali, and Dr. Pradeep Kalansooriya. We are from the Faculty of Computing of General Sir John Kutalawala Defence University. So this will be the content of our presentation. And we'll move on to the introduction and the problem statement first. So we all know that road accidents are a huge issue since decades. And also according to the statistics of the World Health Organization, 1.3 million of people lose their lives on roads every year. So obviously this is a great issue. And also from other statistics of WHO says that for kids and young people in the age group of 5 to 29, road traffic injuries are the greatest cause of death. And non-fatal injuries affect between 20 to 50 million of people that results in disability every year. So this figure 1 shows the latest statistics, although the final year is 2016. And according to this diagram, it's clear that except for few WHO regions, all the other WHO regions are experiencing a higher number of death rate over the past few years. So then we'll move on to the solution. So as a solution to this issue of higher death rate and even the high number of road accidents, researchers have gone for drive emotion recognition paradigm, because emotions play a huge role from activating behavioral responses to decision making. And basically there are 2 approaches to drive emotion recognition. One is using physiological signals and the other one non-physiological signals. So however, from the studies that have been done so far, and from the review work that we carried out, what we could identify is that non-physiological signals like facial emotions, which may differ from one individual to one individual, are not so reliable like physiological signals, which are the biological signals. So we'll see why emotions are this much of concern when concerning the road safety. So to support that, we have some statistics. So according to these statistics, it says that at least 94% of road traffic injuries or crashes are caused by human error. Also, distracted driving caused by emotional distractions is one of the key factors for road accidents, and high-anger drivers drive at high speeds, which are twice as likely to crash in simulations. So obviously, if this is the case for simulations and in real life as well, we will have these values. And bad decisions are also been identified as a key factor for road accidents. So it's really clear that emotions should be governed when ensuring the road safety. So then we'll move on to the research methodology. So to do the literature review work that we carried out here, we use the general procedure as put forwarded by the researchers Templia and Parr for conducting a literature review. So first we formulated the research by identifying the objectives. So as the scope of our research, we are to review the effective state approaches and techniques that have been utilized by researchers in drive emotion recognition paradigm, and to identify the challenges of each of the approaches that we have identified. So then we searched out the literature from IEEE Explore and Google Scholar databases. And as the inclusion criteria in the screening for inclusion, we utilize published work after 2015 to include the contemporary literature to the survey we have done. So then we assess the quality. So the assessing of quality was done based on the study scope by matching the literature that we obtained from the searching. And then we extracted data relevant to the research objectives, like we identified the approaches and the challenges to these approaches. And finally, we analyzed and synthesized the data. So we have provided a critical literature review in our paper, and also we have identified the challenges. We have identified the challenges to these approaches as well separately in discussion section. So then we'll move on to literature review. So like I said, there are 2 approaches to drive emotion recognition. So these are the information that we obtained from literature review work that we carried out from the literature from 2015. So under physiological signals, the used approaches are electroencephalography, electrocardiography, and skin conductance response. And under non-physiological signals, facial emotions, eye blinks, gestures, voice emotions, and even there are some new approach of human expert labeling process, which is known as human expert labeling process, where we involve human experts in labeling by observing the particular individual to be estimated about his or her mentality. So then we'll move on to this table. So this is actually only a summary of the review work that we carried out, although there are multiple research work that we reviewed. So we have categorized it under approach, emotional state, and source. So from the literature review work that we carried out, what we could identify is that when it comes to research in drive emotion recognition, and when it is used, when those use those non-physiological signals like facial emotions, researchers go for multiple number of emotional states, a number of emotional states. Sometimes it may be 4 and it may go up to 6 as well. But when it comes to research in with the use of physiological signals like electroencephalography, EEG, which has shown a good result in identifying the emotional states of individuals, because it obtains the brain signals which have direct correlation between the human emotional states. So this is the research gap that we have identified, because when it comes to physiological signals, researchers go for a minimum number of emotional state due to accuracy issues, because it's really difficult to process EEG, ECG, and other sorts of physiological signals because it's quickly changing nature. So then we'll move on to the discussion. So in the discussion, we have identified the challenges to the approaches that we have discussed in our research. So as challenges to facial emotion recognition, although we have concerned on drive emotion recognition, these are the challenges, of course, faced by all sorts of facial emotion recognition research, such as non-uniform nature of human facial characteristics, lighting, shadows, orientation issues, and pose illumination and age invariances as well. And interpersonal differences also affect the simplicity of using facial emotion recognition approaches. And as challenges to voice emotion, selecting a speech database, or else if you are conducting a sort of experiment to collect the sound or the speech database, and identification of varying features with regard to speech, because there are different pronunciations when it comes to the world context. And selecting a speech classification model, reduction of noise in speech are some other challenges that have been identified under voice emotion recognition. So as challenges to electrocardiography-based emotion recognition, actually, it's really hard to detect the particular emotional state specifically, because increase in heart rate occurs on fear, excitement, or arousal. But we can identify it's some sort of negative influence or some negative thing that's happening inside the individuals. But still, specifically identifying emotional states from ECG is quite hard. And the correlation selection between subject-dependent and subject-independent classification procedures is some other challenge that we have identified based on ECG. And when it comes to EEG emotion recognition, actually, this has proven for its efficiency, because having EEG signals, which makes use of the brain signals of individuals or the drivers, or else even for the basic emotion recognition for other individuals as well. EEG has proven for its efficiency, because it obtains the brain signals of individuals which have a great correlation on the individual's emotional state. And the ineffective, however, there are some challenges to EEG as well. Ineffective exploitation of the topological structure of EEG signals to identify varying EEG representations, because some research focus on having also the electrodes on the scalp of the particular EEG acquisition experiment, while some concern on the combination of electrodes of the particular EEG device that we are using for the EEG acquisition. But still, the correct identification of the suitable electrode combinations is quite difficult, but still EEG has proven for its efficiency, whatever the combined electrodes that we are having. So also quickly changing nature of EEG signals is being identified as one of the challenges. So actually this is being identified by all sorts of physiological and non-physiological as well, because even the facial emotions vary quickly. However, not producing the required emotions when emotion eliciting stimuli are being watched is also identified as one of the challenges. And actually, this happens when the feedback while performing the particular EEG-based emotion recognition research for collecting the EEG data set, or else any other data set, is not done with the particular feedback, because we don't know, although we intend to arouse particular emotional state on the individual's mind, it may not happen. So definitely we have to go with the particular feedback means where we can obtain how individuals felt while having the emotion stimuli environment. And as challenges to galvanic skin response based emotion recognition, obviously we know that GSR is based on human skin conductance response. So we are concerning the human sweat glands. So when it comes to GSR-based emotion recognition in drivers, it's quite difficult because if the automobile that we are considering, definitely we go with air condition mostly when it comes to drive emotion recognition approaches, because it's really hard if we are having the motorbikes and all. So it's quite hard to have GSR in emotion recognition for drivers because air conditioned automobiles are being widely concerned in emotion recognition for drivers. So then we'll move on to conclusion. And so we have done only a literature review work here where we will be doing our final year project based on EEG, which has been identified from this research that we carried out to select the particular approach that we are concerning. So drive emotion recognition approaches have gained wide attention based on road safety, and the use of physiological and non-physiological aspects are widely being identified. So however, accuracy issues have led physiological approaches to not to be used to a great extent when the number of emotional states are being concerned is identified or regarded. So these approaches with physiological signals go for a maximum of 2 or 3, which we have identified as a research gap, although multiple emotional states are being concerned in non-physiological signals like facial emotions. But however, research say that physiological signals are much more reliable than non-physiological signals in detecting the emotional states. And this review work provides further insights into research in drive emotion recognition by minimizing the challenges that happen from them. So these are the references. Thank you very much.
Thank you very much, Ms. T. Gamage. Now the floor is open for question and answers.
Did you find, now you have identified several challenges with respect to different factors. So throughout from your literature review, have you extracted any solutions for those challenges? Any hint for that?
Yes, so when conducting the acquisition of data, if we say for EEG, so if we use some particular a well-followed procedure to minimize the outside noise, so it will be of great advantage because in pre-processing step, it will really help. And other than that, having different combination of electrode positions will also be efficient in getting a higher accuracy as well. And yes, so pre-processing works really well if we can use some sort of good technologies like EEG Lab, which has shown good results in EEG pre-processing.
I have one question. So when you take about this categorizing the EEG signals and whether you are going to categorize them, whether these drivers are fatigued and now they need to take a break or something, are you going to suggest something like that in your system?
Yes, madam. So actually we are going with EEG. So we have come up to EEG emotion classification. So we are doing the work on detecting EEG in real time, but still it's sort of issue because connecting the particular brainware with the system that we are implementing is quite hard because for that we need a lot of amount, like more than $1,000 to obtain the license for the particular EEG device we are using, because we are using some commercial EEG brainware. So yes.
Yeah, so the other question is that when you are considering some of the experienced drivers may be having their perseverance level at a higher level. So there I mean the level that if you have a benchmarking value, so some of them it is a kind of a individualistic measure. So have you thought about in that context taking the environmental context into when coming into reasoning? So have you, I mean, I'm just giving you a suggestion. So you can think about taking the environmental context into reasoning, as well as taking in the what you call the personal characteristics. So if you want to advance it into a next level, so you can embed that component as well, rather than totally depending on the EEG only.
Thank you, madam. Thank you so much.
All right, thank you. Are there any more questions? All right. In the absence of any more questions, I would like to wrap up the session. Today we had 5 papers. First of all, I would like to congratulate all the presenting authors as well as all the other authors as well for their great achievement. So some of you, this may be the first time that you have presented a paper, and I hope you will be continuing your tradition, your research work, so that you come into greater heights. Another thing I really want to appreciate is, in the absence of the one author, it can be any situation, a sudden situation, unavoidable situation. So it's a shared responsibility of the other authors as well to replace and continue the program without any interruption or anything like that. So I would like to thank the author for thank the author MAST Gunathilake for setting that precedence. So I hope that there are so many other undergraduates. So you will realize the value of shared responsibilities and taking the work ahead. With that, I would like to conclude the session, and thank you very much.
Thank you, Madam. Ladies and gentlemen, we have come to the end of the Computing Technical Parallel Session 1. Now, I would like to invite Dr. DDM Ranasinghe, the chair of the session, to present the certificates to the presenters. Mr. KMCM Karunanayake, Ms. T.A. Gamage, Ms. T.N. Nicklesha, Mr. J.K. S.L. Jayakodi, Ms. T.A. Gamage. Thank you, Madam. Please remain as you are for a moment. Now, I would like to invite Vice Chancellor, Major General Milinda Piris of General Sir John Kothalavala Defence University to present the token of appreciation to the chairperson. Thank you, sir. On behalf of the organizing committee, I would like to extend our gratitude to Dr. DDM Ranasinghe for chairing the Computing Technical Parallel Session 1. And with this, we conclude this session, and I cordially invite all of you for refreshments. Ladies and gentlemen, please be present here at 10:30 a.m. for the Technical Parallel Session 2 on the theme of Smart Decision Making through Deep Learning and Data Engineering. Thank you and have a pleasant day.